Who is first time on my presentation? Lucky you. Maybe I'm tired, but somehow, if you want a good performance from me, you should give something back, right? So there's two rules in all my presentation. First of all, no empty rows, first rows at least. So everyone that's sitting on the back and hiding from me, you really shouldn't. So here he see at least free places. Here a lot of them. Come closer, really. You will enjoy it much better than sitting on the back. Come on, guys, don't be shy. Идемте сюда, на первой линии, вам реально будет круче намного тут, чем вон там прятаться. А мне будет намного приятнее говорить не с пустыми креслами, а с людьми, которые вот они тут рядом, и вас много. Круто. А второе правило, что нужно как-то повеселиться началом. Поэтому, чтобы такого сделать... Не будет костюма Чубайки. Не в этот раз. Who's from Minsk? Okay. Keep your hands up. Who is not from Minsk? Martin, you should come closer. Sit here. So keep your hands up. Keep both hands, like if you're like Minsk and not so. Now you need to clap with your neighbor and say your name. No, come on, guys. Do it like what? No names. I'm Vladimir. Why not? Because I can. My name is Yonatan. I'm from Israel. I'm doing various stuff in my life: startups, development, bullshitting, and other things. Not so far away. Only 1 year ago, even less, I was part of the Get. If someone don't know, you probably know Juno. So Juno now is part of the Get. Get is an amazing startup that started really, I was employee number, I think like 7 or 10, something like this. Really small startup. They started in the middle of the Tel Aviv, then exploded to 2,000 employees globally, 4 continents, offices all over the places, including the Belarus. Amazing place, amazing company to be there. But suddenly I left the company to find my own startup. It's called KolGene. It's in the genetic fields. We platform to ordering and managing genetic tests. Sounds like artificial intelligence, but like science fiction. But trust me, it's not. It's an amazing thing. So if you will ever wonder what is the DNA about, what it can tell you about yourself, come to me. I will tell you a lot of jokes about it. And today we're going to talk about Galaxy, Star Wars, how is not? So if you don't know about me, all my talks is about the Star Wars. I just like the topic, it's cool. But actually, the story starts not on the Star Wars, but on the Wild West. So basically, Android, right? Who here is an Android developer? I'm just curious. And the rest, like, what are you doing here? Why? Okay. Android, from the first days, is the Wild West. Every single developer was allowed to do almost everything. To screw up, it's in every single possible way, dozens of the possible ways to create crappy application that was draining the battery from 100 to the 0 in 3 hours, like mine, for example. And literally, it was like no rules. No one is telling you how to do that, how to improve the application, how to save the battery, how to save the Galaxy, and provide the better user experience. My first application actually is the true. This is the screenshot that I saved for myself. So I was like able to drain the battery from 100% to almost 3% in less than in 3 hours. This is my personal achievement, and still can't really beat it. I really try harder, but the fact that actually it's still true in our days, that there are some applications, small applications that fucking drilling the battery like very constantly. I have no idea what they're doing behind the scenes. I tried to reverse engineering, and the only thing I found that there was like actively listening for everything that I'm talking on the phone, for example. They like What? Why? And the answer is because they can. And then actually, Google guys start to do some various things in order to improve that. And first one was introduced in the Marshmallow, and then what was improved on Nougat. They introduced something called DOS. Okay, who's know what is the DOS about? Right. So for those that don't know, DOS mode is actually that the device, once it's turn it off, it's starting to dosing. So basically, it's start to cutting every request for the network, GPS, Wi-Fi scans, Bluetooth scans, and basically, when you will try to access, for example, network to send the request, it just put the whole process in the sleep. It's start to do in maintenance window. So basically, if like this is the graph, so this is the device how it's active. Okay, network request, and then actually he put the DOS like active for let's say 2 minutes, 3 minutes, and then all application receive the maintenance window that they can continue to use GPS network and all the stuff. And then again, it put the DOS mode that nothing can be accessed, no application that can access internet or other stuff. And then again, DOS, and then actually, as long as the device remains asleep, the window of the DOS become much larger and larger. So actually, from my statistics that was running, if you're really curious to hear more about the DOS, I have a separate presentation about it. I think it was on the DroidCon London. You can watch it. So in short, after something like five active windows of DOS, it becomes in hours. Okay, so actually the device starts sleeping in hours. So if you will disconnect at the night, you will disconnect the charger and will put your phone near your bed. You will discover so that your battery almost remain the same. Why? Because of the DOS mode. But still, somehow there are applications that were screwed it up. So if you know it's a WhatsApp web application, and if you know the WhatsApp web application using WhatsApp mobile application in order to make this work. So actually, when they introduced the DOS mode, then the Google introduced the demos, the WhatsApp was sucking a lot, like it just really doesn't work. So actually, this was the first sign for the application developers like Hamon guys. It's not like everyone allowed to do anything they want. You need to adapt to the new rules. And new rules starts with background services. And still, somehow, even with the DOS, there are some certain ways that you can still running endlessly services and without even notice to the user. So like, this is just a small example how you can do that. You create the service, you start it, like create the looper, handler thread, and that's it. You can run endlessly. Nothing is going to stop you, right? So you just drain the battery. The CPU is never going to sleep. Not so good. And there are some improvements that still can be made. So in order to show you how we can improve the stuff, I built a small application. And this small application, Darth Vader, Luke, father and son, the most things our parents are worried about is where are children. So like, let's imagine that there are application on the Luke Skywalker phone that sending every 5 minutes location to this father, okay, to the server. This is the case, right? Every 5 minutes, we want a location of actually where my son is, right? And the application is pretty simple. So there's a main activity that's showing some user interface, and then it starts some service. Service create the handler thread. Handler thread create location handler, okay, to handle all location requests. Who is here not familiar with the handler threads, handlers? Cool. Yeah, don't be shy if you're not familiar. So the basic idea of the handler thread is actually it's a separate thread, okay? It's like really separate. It's another thread that using there's a lot of things that happen under hood, that actually the handler thread is created a separate looper. The looper is the one that actually constantly querying the messages and proceeding to the handlers. And the handlers are actually proceeding the messages one after each other as looper bring them to the right handler. So it's like small in a nutshell. So we want every 5 minutes location, right? So actually the handler going to send message to himself every 5 minutes. Okay, so send the message delayed. In 5 minutes, get the next location, next location, next location. As long as the server is alive, we will have this location queried. Then we have like the location tracker itself, right? To find the GPS, the network, the correlation, what's the best location, blah, 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 blah. And then once we have a location, right, because it takes some time, it could be new location, old location, how to figure it out. And then once you have a location, you will send the broadcast receiver, not RxJava, no this bullshit. And then actually, it's sent to the network handler, right, to send it to the Firebase, for example. I was too lazy to implement my own server, so I used the Firebase to store the all locations. Are you filming? Like, wow, genius architecture, right? So in the code, I remind. So actually, there's some problems. There's a lot of problems here, but the basic problem that these servers every 5 minutes could be stopped in every second, right? Someone can kill the process, right? There's no memory, the memory is pressure, let's kill the process, right? So what we need to do, let's put the alarm manager that will wake up every 5 minutes and will check if the server is alive. If it's not alive, it will start again, right? Is it enough? Not really. What happened when the device is rebooted, right? So everything needs to be rescheduled. So let's put the broadcast receiver that will receive the boot completed, and then we start the service and the alarm manager, all this stuff. Okay, so how does it look in code? Like I will go with you briefly. So the main activity, it's the service. I call it native service. So the one that creating the handler thread, it's taking the looper, and then it's creating the location handler, network handler. It's create the new broadcast receiver, and then once we receive the let's get work to done. What you want to interrupt me? Of course, Женя. Перегрузка. Матрикса перегрузка. Куда ты меня добавишь? Могу так. Okay. So once we get the command that we need the location, then we register our receiver, right, to get the broadcast about the new location. Then we remove the past messages if they at all. We send the new message like getter's new location, and we return what we're returning in the service. What? When you start service, what you're returning? Which ID? No, start sticky, start not sticky, compatible, not compatible. Doesn't matter. And then actually we are like good citizens of the Android, right? So we need to clean the things once the service is down, right? So we need to clean the handlers, we need to stop the looper, we need to stop the handler thread, we need to remove all location query, etc., right? I hope you're really doing that. Otherwise, you're creating the memory leaks if you're not cleaning the stuff after yourself. So how the location handler is looked, like if you're not familiar with the handler, so you just take the looper, we create the location tracker is my own class that I wrote. And then you, in the handler, you start to receive the messages, and you send the message for yourself delayed in 5 minutes, right, for the next location. And you ask location, start to track, and actually to obtain me the next available location. And also we need to stop it, right? How we obtain the location, like we're just requesting single updates from or GPS or from the network. There's a lot of logic that built behind that, like that I built. I will show you with your code. It's like small snippet from what we was doing in Get. How you obtain the best location, like there is a lot of knowledge. What is location is the best one? The precise, the accuracy, the timing, the source, etc., etc. But it's not really important. The structure is important here, and try to get the idea of how I build it, how I screwed it up. So actually, we start the service, we start the handler troop, handler thread, we start the handlers, and then the location handler start to query itself every 5 minutes to get the updated location from the location tracker. That location tracking using GPS in the network, and then once he gets the network, he send it to the broadcast receiver, right? So we check the weak reference of the context, right? Because we need to send the location tracker is not the Android framework component, right? So we need a context. We not store the direct reference for the context. Who is like storing the direct? I just curious. Direct reference for the strong reference for the context. Why not? Whoa, whoa. Okay, so the best suggestion: don't leave the direct reference for the context. Otherwise, you're creating the leaks. Use the weak reference context, weak reference. And actually, once you have the context, you can create the intent and send it to the right receiver. Any suggestion why I'm using here local broadcast manager and not just context, send broadcast? Why is that? Why is that? Like, why care? What does it mean security? I ask Vanya. Yeah, I know they know. They're always, they're like not the first time.
It can provide messages only for our application.
Ta-da-dam! We have a winner. So the idea that behind it is actually it's because we're sending implicit broadcast. It can get brought to the hands of other applications, for example. So we need, if you want to stay only in our application, we use the local broadcast manager, and it's only going to send the implicit broadcast within our package. Just like 2 minutes of. And then actually, once we receive, we get the location. We create the new message to send to the network handler, right? So the location handler is not like the one that taking care of the network, right? We need to separate the logic, abstraction. Cool. And then actually we sending it to the network handler. And once the network handler receives the report, we just take the location, create the server report, get the instance of a Firebase database, and put it in database. That's it. Questions about that? Like, it totally wasn't clear. What the hell you were like? Yes, Pavel. Wow, good question. Amazing question. Yes, like you should like grab the strong reference within that, but I just was lazy enough to not doing, because the chance that it's going to be cleared and like it's very low. Like it's taking time to clear the context. So the result of that. Any other questions? Yes. No. Yes, Pavel. So start sticky, it starts the service if it was killed because of the services of the component itself. But once I kill the process itself is not going to recover.
You need the process, not the service.
Right. So if like the Android managing the LRU list of the components, and there is LRU list of the processes. It's two different things. The service could be killed, but the process could be alive. Okay, so once the service is killed and it starts sticky, the process will start the service again. But if this process was killed, for example, like force stop or any other particular reasons, it was crashed and other stuff, nothing going to restart it. Okay, so you need something that will start implicitly. I was running this for the I think almost for the whole day, like from the morning till the late evening. And these are locations I got. Like I was like, Luke was at the home, and then he's like driving to the work, and blah blah blah, and then like I stopped location. So it was like about 192 locations. Okay, any guess how much battery I drained? Full? No, it's like it's almost. So actually, I 7 hours of work I succeeded. It was top one in draining batteries. It was 60%. 60% is like, if you will, like say, the average device can last for the 18 hours. Quite a lot, right? And I was like only querying the location once in the 5 minutes. What if the application doing other stuff? It's like, so the problem is still exists, right? So I try to be very like gently, not to query location, not even 1 minute, like only once in the 5 minutes, like not doing some heavy stuff. Try to be as much as performance as possible, right? So what actually the other thing is actually what's going to happen on latest release, and who knows what's happened with the latest release, the Android Aurea, except of you know guesses. No one knows. Okay, Pavel, give us a. Right. What else? What else happened? No, guys, come on, wake up. It's already not morning. It's almost 12. The question was, what happened? Like, so we had this amazing application that drained 60% of the battery only by querying once in the 5 minutes the location, right? It's worked amazingly. But now we like in Android Aurea, right? Android SDK 26. Now it's even 27. So what actually happened in SDK 27 that's related to the story? So we have first answer by Pablo, sorry, that the service now can be run for a long time. Right, receivers. So there is no explicit or implicit. There's no explicit, the one that you can define with action, right? Explicit, I'm always confusing myself. Explicit or implicit? Explicit. Explicit receivers. So you can't like say like, I will register my receiver for action like connectivity, for example. No, you're just not going to receiver. In the static manner, you can still register in the programmatic manner. I will. What else? Yes, name. Andrew. Right. The other thing is like the location is going to be received only once in a few hours, only a few times in an hour. What else? It's not over.
As I remember, we can use locations that are fetched by another application.
Right, but it's not related to Android Aurea. It's like we can use get last known location, and if someone already queried, we'll get it. So let me guide you. So I was running my application, the same one that I built on Android Aurea. And guess what? From the whole life of the 7 hours that I was running, by the way, I was like going with the 4 different phones at the same time. So on same application, on Android SDK 26, I got on one location. What? Like, why is that? With all this amazing stuff that I built with alarm manager, bootloader, and like recurring itself, like why does it happen? For example, my phone wasn't asleep. I was using it like the middle of the day, you know, going to the work, using the GPS very actively, by the way, like with Waze driving from my home. Luke was driving from his home to the office and like and doing other stuff, right? So my phone wasn't asleep. Okay. Yes, Andrew. Right. This is one of the reasons. So there's a couple of reasons. The first one that no one really mentioned is the Wakelocks, right? Who knows what is the Wakelock? Okay, so for those that don't know what is the Wakelock, Wakelock is actually the CPU can go for sleep, right? And then what it's doing for the threads is just park it. Okay, just like taking the thread, park it aside, and actually the whole thread is going to like, sleep. Okay, so in order not to happen, you have to hold Wakelock. Okay, you literally go to the power manager. I will show you the snippet of the code. You take the Wakelock. And you ensure that in this time of this code is not going to be everything of this method of this code going to be executed until you release the Wakelock. So actually, all Wakelocks in a Android SDK are dead. So once your service is in the background, after 1 minute exactly 1 minute, right now, this is the configuration, by the way, all Wakelocks are going to be released. Okay, so basically your CPU can go to the sleep without being interrupted. And you're not allowed to establish new wake, to acquire new Wakelocks. Start service. You're not longer allowed to start service in the background. So once your application, like for example, you register some receiver and you want to start service, you will get, in your application not in the foreground, you will get a legal state exception. That's it. You're just not allowed to do that. No more Wild West. And all the static receivers, right? So we like to get things done once other application take a photo, for example, or we get SMS. So like, no more. We're not going to use it at all. You will not going to receive anything of that. Still, it's work when you register it dynamically with a context register receiver. And as Andrew mentioned, we're not allowed to receive any new location. Like, we're only allowed to receive few locations in 1 hour. Okay. So actually, how we adapt for the new architecture, for the new end of the Wild West? Or actually, how are we going to save my 6% of the battery? And then actually comes Job Scheduler. Job Scheduler is something that was introduced in the API 21. A lot of developers are afraid to use it somehow. I don't know. There's like totally, why I should use it? So in our application, I just decided to use it and to see what happened. So it's same activity. Instead of like start service immediately, we take the instance of the job scheduler and we're scheduling to start our service. Now it's smart service, right? So it's smart. They're doing a lot of things smart. And start service, and the rest of the things are the same. Actually, we start service, we create a handler thread, a looper, location handler, and then it's going to location tracker. We track the GPS, we get the GPS, we broadcast it, and it's going to the network handler, and network handler update for the Firebase. Wow, amazing changes, right? So many changes. How we schedule the job, it's pretty simple. So we'll, whoa. So actually, I will guide you, I don't know. So I guide you, actually, you create, something that I forgot. So job scheduler is available from the API 21. What are you doing if we need to have minimum SDK like 16? Who have minimum SDK 8? I'm just curious. Anyone? 16? What, no? 16, 1.6. What do you have the rest, like 21? 17. Okay. Anyone with a minus SDK 21? Wow, you lucky guys. I'm fucking jealous. These guys are really lucky. They have a bunch of APIs that working really well. So if you, like me, stuck on the 16, you have to use something else. So you can't use job scheduler because it's only from the APIs 21. There is a job dispatcher that actually comes from the Firebase package. It's the same as job scheduler. Even when they're running on the SDK 21, it's going to use job scheduler underneath. Okay, so basically it's almost the same code. The difference are pretty small. So the job dispatcher is just coming from the Play Store package. Actually, from Firebase package, it's coming from the Play Store package because it needs Play Store underneath. So you need to have the Play services. And if you're like operating in China where there's no Play services, then you have to use it's from the Evernote is Android job dispatcher, something like this. Okay, I don't remember, but you can look for the Evernote Android job dispatcher. You will find the link. So basically, to create a job is pretty simple. You just create the job. You set the service which one is going to run. You're going to set the job ID. It's called set tag in my job dispatcher, job ID in the job scheduler. It's very important. And then if you want to have it, hey, thank you. And then if you want to have it recurring, like happening every time, right, in the window, you just specify that it's true. If you wanted to have it running all the time, even after the device was rebooted, you don't need any particular receiver that will receive the bootloading and then start the service, you just specify set lifetime forever, and then you will have it the job scheduling again once the device is rebooted. You specify the trigger. For example, we want it every 5 minutes, so actually we specified the window. Because the job schedule, how does it work? It's not like exactly running in the same frame that you defined. It have own set of rules that basic on the criteria that I'm going to explain in seconds, and it's based on the actually the lifetime of the device itself. Wow. You define the constraints, you define the trigger, and then actually build, and then you schedule. If you want, and how does it work in the service? It's the same. You have an on-start job, on-stop job. So basically, on-start command, on the store, the same stuff. Where you just you grab the interface, you grab the broadcast receiver, you start the location tracker, and once you stop it. The difference is huge. You see, actually, on the map, the difference is not so. So I have like most of the locations I was in one place, right? At the home, at the work. I get almost the same locations along the route, but the number of locations used is like fourth part of it. Any guesses how much I drained the battery? What's the 10 minutes? No way. Martin ate all minutes from me. So any guess how much battery I drained? 10%? The question is even less than 1%. And I wasn't able to measure it with a real device, with the one that you check in with the battery. I was needed to take the battery history because it was like so low. You just like the way this job dispatchers works, because it's combined, works together. So actually, it's not really draining the battery. It's used the biggest drain of the battery. You know when? The GPS and the network, the radio. So once they combine the requests together in the execution window, it's really saving your battery. So how does look the same code on Android Oreo? It's basically the same. Nothing really changed. And the question, is it really so good? So it works. It provides a lot of value. But there are some like hidden bits that you need to take in account. So as I mentioned before, there's a Wakelock that's released once the device is putting your process in the cache state. And so basically, once you start the service, you have a thread inside of it, right? So we have a handler thread, and then actually, if our process is killed and we still have a thread and Wakelocks inside of it, it's going to be released automatically by the system, right? So this is basically what the documentation is said. In reality, I decided to test it. So actually, I created two services. Actually, one service. It's regular service. On the start command, I was like taking the Wakelock. So go to the power manager, grabbing the Wakelock, and I'm starting new thread. Right? Very simple. Nothing really handler thread, not async task, like just simple thread. Right? Very simple. I grab the thread, I acquire the Wakelock. Okay, not allowed to the thread to go to the sleep, and then I'm like doing some work, like thread sleep, just like running constantly. Right? So basically, what I did, I leaked the thread intentionally. Right? So I have a thread that's running, so nothing doing in the stop. And then I should start the thread, and that's it. So the question, the quiz. What's going to happen? The first is after some time, the service will stop. Okay, Wakelock will release, and the thread will be parked. Park is meaning like it's went to the CPU is parked, and actually the thread is went to sleep. Second option, the service will die. Wakelock will be never released. The thread will run till the process is killed. The third option, that service will continue to run till it's stopped. And actually, service will die till the process is stopped, yes? And the fourth is actually the service will die, system will release the Wakelock, and after some time, the thread will be parked. What's the option? Who guess? Who guessed what? What's the right one? Bam. I make a mistake. So basically, 3 of them. I meant something else. Don't remember. 11 p.m. One of the threes, which one is the right one? First one. Who said the first one? Service will die, Wakelock will be released, the thread will be parked. Okay, the second one? Okay, the third one? And what's about the rest? We don't have an opinion? Third one. Okay, so yeah, let's make it dramatically. No, come on guys, why is and the answer is number 2. So actually the service will die, but the Wakelock will never be released. And the thread actually will continue to run intensely and just drain the battery. How we figure it out? So actually I dumped the device and you see the small things like it's cached through. So actually there's no active components. You will not find the all dumps as any one of the active components. So basically it's empty process. Everything is cached. It's in the cache set. But still there's a thread that's running that with the Wakelock and the Wakelock never released. It's even confirmed by the guys from the Android team. Like, yeah, we have a bug, fill the report, we'll take care of it. So, yeah, 5 minutes. Cool. So, the last tip and tricks of dealing with all this stuff. First of all, as you saw, there's a lot of problems inside of it. Right? There's a lot of things that happen, then you need to take care of it, don't care it as granted. If Google wrote something, it's not necessarily true. Sorry by that. But this is actually how reality works. There's a lot of bugs. So first, my first tip. By the way, all my applications are built on with a job schedule, actually with a job dispatcher. Okay, so and all my tips is built is basically on my personal experience. So take it like my 0 cent of truth is not necessarily truth for everyone. So first of all, maintain the progress. Your job could be stopped in any moment. So basically, when it's stopped, check the progress that already was made. For example, like if you was middle of the download something, or minimum of the upload, or minimum of some middle of some complex job, don't start it over and over again. Maintain the progress. Verify where you stop, and then actually when next time you're going to receive time for work in your service, start not from 0, but from the place where you was stopped before, right? Backward compatibility. So I said job scheduler is from T21, job dispatcher requires plate services. But what if I need to have something that, like, I want to run my job right now. I don't know what is the service, or it's like it's job scheduler, what I need to rewrite everything to use the job dispatcher, job scheduler. And the answer is not. Actually, you can use something they call job intent service. So one of the things is coming from the support library. So it's available for you now. And underneath it use 2 things. The first one is like actually is going to use context start service if it's like less in SDK, less in area, less than 26. So basically you're going to have the same functionality as the service. So if you want to migrate all your service to be compatible with Android SDK, 27, 26, basically use the job intent service because it's underneath going to use context start service. And if it's area, going to use at job scheduler and cure. And cure is actually based the same as scheduling the job, just with time 0. So basically, execute it now as soon as possible. But it's not guaranteed that it's going to be executed right now. The system will try to do the best. Okay. Basically, if you like using job scheduler, so basically to migrate from the on-start job to handle work, or on-stop job on stop current work, or like if regular servers from the start command to handle work, on destroy to on stop current work. I mentioned before the job ID. And job ID is one of the issues that I have really a lot of the time, is actually that the job ID is required to be unique across all applications installed on the phone, not just only your package. Okay, and it could create problems because like I was smart, so I used job ID number 1. And someone else also used job ID number 1. So we like, and it took me time to figure out why my jobs was like constantly rescheduled, and I guess his job as well. So basically, you need to create some kind of job ID manager that will create unique job ID based on the package, based on the version, and like to manage it in yourself. Don't make my mistakes. Another thing that, like I was saying, you don't need to reschedule. The truth is, you don't need to reschedule the job, and you're not using the boot ready receiver. on the Pixel device, but somehow it happened to me that on the Huawei device and the OnePlus device, the job was never rescheduled. I have no idea why. I didn't dig in the code, but like it doesn't work. So basically, you still need to back up with receiving boot and reschedule your job underneath. There is a bug that opened on the bug tracker. And the last thing, you see, I'm finishing on the time. I really practiced. So the last thing I want to say to you before we're finishing is that actually, you know how the phone without batteries looks? So once your application is draining the battery, actually you're killing usage for all applications. So basically, it's like not only no users for you, it's actually no users for others. So be kindly and user-friendly to the system and like help us to save the galaxy and to leave my phone with the battery. That's it. Thank you.